Last type of series we need to consider is an alternating series. Basically, what an alternating series means is that you have a series where the terms go from positive to negative to positive to negative, right? Their signs are alternating, or negative to positive, so on and so forth. Right? And the one we might consider to begin with is this series. The sum of the series from k equals 1 to infinity of negative 1 to the k plus 1 power over k. Now this alternates because with every change of k, and when k is 1, we have negative 1 squared, which is positive. When k is 2, we have negative 1 cubed, which is negative. When k is 3, we have negative 1 to the 4th, which is positive. Right? So it's going to bounce back and forth. Right? And notice that the terms in this series are going to be 1 minus 1/2 plus 1/3, so on and so forth. Right? So it's alternating and it's harmonic. So we'll have to make some sense of what's happening with this. Now, for the test, if the limit as n goes to infinity of the nth term is 0, right? So the limit of the nth term is 0, and notice that this is the rule absent the negative 1. And here's the other piece. And that 0 is less than a sub k plus 1, which is less than or equal to a sub k. Right? So a sub k plus 1 would be the term after a sub k. And really what this means is, are the terms decreasing? Are they decreasing in value or not? And if both those things are true, that the terms are decreasing as we get out there, it might not be decreasing at the beginning, and the limit of the nth term is 0, then the series is convergent. And then an alternating series converges. So if we go back to our example and consider it, the sum of the series from k equals 1 to infinity of negative 1 to the k plus 1 power over k. A sub n in this case is 1 over k. Right, that's the rule absent the negative 1 portion. And so the limit, I guess it would be it'd be 1 over n. The limit as n goes to infinity of 1 over n is 0. So that's the first condition is met. Now notice also that 1 over n plus 1 will always be less than or equal to 1 over n. So the terms are getting smaller. The limit of the nth term is 0. The terms are smaller. This means that that series converges by the alternating series test. Now we might consider a different series, something like the sum of the series from k equals 1 to infinity of negative 1 to the k plus 1. Right, and that part just lets us know it's an alternating series and that the first term will be positive, the second term will be negative, so on and so forth. And the rule of the terms besides the sign is 2k plus 1 over 3k minus 1. So there's two things we want to know. What is the limit as n goes to infinity of 2n plus 1 over 3k minus 1. The limit, in this case, is 2/3. We can immediately conclude that this series is divergent because the limit needed to be 0 in order for it to possibly converge. Right. So if something's going to be convergent by the alternating series test, we have to have an alternating series. The limit of the nth term must be 0, and we need to be able to decide, are the terms getting smaller or not? Now, sometimes it's really hard to tell if the terms are getting smaller or not. Consider the sum of the series from k equals 1 to infinity of negative 1 to the k plus 1 times the square root of k over k plus 1. We will find that the nth term of this will be 0, right? The degree of the numerator is bigger than the degree of the denominator, so this is going to go to 0. But the hard thing is what's going on with this, a of k plus 1 compared to a of k. Is this true? And that's difficult to tell on this. But a way to consider it is that there is a function in terms of x that would be the square root of x over x plus 1. And that function has a derivative. Its derivative is negative x minus 1 over 2 times the square root of x times x plus 1 squared. And the thing to notice is that this derivative is always less than 0 for x greater than 1. Right? Because as x gets bigger, the numerator will be positive times a negative, and any value of x, the square root of it will be positive in the denominator. Something plus 1 squared will always be positive, so the denominator is always negative. Well, since the derivative is negative for x is less than 1, then we know this function decreases in value. And since the function decreases in value, that means that the terms of the series are always going to be getting smaller, so we can conclude by the alternating series test that our original series converges because the limit of the nth term would be 0, because I have k to the 1/2 over k to the first. The degree of the denominator is bigger, which means it goes to 0, and everything is decreasing. So we can make this conclusion. This is the alternating series test.